Hello everyone. On this episode of Tinkering with Terrius, I'm going to test out the component tester here. I've got some resistors, some capacitors, some transistors, some LEDs. The other thing I wanted to show was how to run the self-test on it. So these three pins here on the left are considered socket 1. This pin is socket 2, and these three on the right after the divider are socket 3. So there's two ways that you can start the self-test here. You can link socket 1 to socket 2, and then you can link socket 2 to socket 3, and you can power up the unit, and that will ask you if you want to enter self-test mode, and you say yes. When it comes to isolate probes, you remove the wires. Now it's going to ask for a capacitor greater than 100 nanofarads. So I have a 10 microfarad one here. Let's see if that's good enough. And there we go. Until you do that self-test for the first time, it will come up and say that the device isn't calibrated and that it needs to run a calibration. So it's good to do that first thing. The other way you can get into it is by coming into the menu. And in the menu here there is an option somewhere here for the self-test. Same thing, when you go in there it'll tell you to connect all three pins, and then it'll tell you to isolate them. Then it'll ask for a greater than 100 picofarad capacitor. So it's really easy to do that. Okay, so now that we have it calibrated, we're going to test some resistors first. So the first resistor I have should be a 10 ohm resistor. It's a 10 ohm 0.1% resistor, so we'll see what it says. 10.1, that's pretty darn close. Now we'll try a 100 ohm resistor. So for these I'm connecting them between socket 1 and socket 3, just because it's easier. So again, this is a 0.1% resistor, so it's coming up at 99.7. So that looks like it's good. So now we have a 1000 ohm resistor. So 1002. Okay, next up we have the 10,000 ohm resistor. So 10,000.04. So we have the 100,000 ohm resistor. So it's saying 99.68 thousand ohms. And finally here for the resistors we have a 1 meg resistor. It's registering 999. So 997, 98-ish thousand ohms. So that's pretty close. It definitely seems to be more accurate at the lower resistance values. So I think next here we'll try this diode. So it's showing up as a diode. Forward voltage of 251 millivolts. We'll try an inductor this time. So it's telling you the resistance here. Value here is 0.08 millihenries, and this is a 82 microhenry. The fact that it doesn't go down to microhenries is kind of a disappointment, but it works. Test this orange LED, see what it says. I put it so the flat side is on this side. We'll see what it thinks of that. So So the cool thing is it blinks the LED a couple times. So it's telling me the forward voltage is 1.86 volts, capacitance of 5 picofarads, green LED that I salvaged out of something. So same thing here, you can see it blink a few times there. This one comes up at 1.95 volts with 15 picofarads. So this is a potentiometer. Just curious what it shows up as there. So potentiometers look like they show up as two resistors in series. So I think finally here we've got a few capacitors to try out. Got this little tiny ceramic one. (197 picofarads). So I think that's about right, because I believe this is about a 200 picofarad capacitor. It says 220 on it. Next capacitor here. It's coming up as 313 picofarads. Final ceramic capacitor that we'll try out, and this big one here. And that's showing up as 86, slowly climbing, nanofarads. So I think it's safe to call this one a 95 or 96 nanofarad capacitor with 1.4 ohm equivalent series resistance and a 0.3 to 0.4% voltage loss. Unfortunately, I don't have a multimeter that can read capacitance, so I can't really compare the tester to anything. So let's try out some electrolytics now. So it did have an important note in the manual to make sure that any capacitors you put in are discharged before you insert them, because otherwise you could end up frying the circuitry on the tester itself. Here's a 10 microfarad capacitor. And the nice thing is it doesn't matter which direction you put this in, it detects the negative and positive sides. So you can see that one read pretty quickly there. So it's a 10.9 microfarad with an ESR of 2.0 and a voltage loss of 2.8%. So we'll try a 22 microfarad one next, with it saying 26.8 microfarads, ESR of 0.69 ohms, and a V loss of 1.7%. So next here I'm going to try a 100 microfarad one. This one is brand new, just got it from DigiKey 2 weeks ago. So that definitely seems pretty accurate. This was a 10% capacitor, so 102 microfarads, it seems pretty good. 0.28, 0.3 ohm equivalent series resistance, 0.7% voltage loss. Final test is going to be this colossal capacitor. It is a 470 microfarad capacitor. It has 500 and some odd microfarads with no ESR, which is interesting, and a V loss of 0.8%. So from what I can tell on this little component tester, it seems pretty decent. The big downside that I see with it is that it doesn't just turn off after a couple seconds. If the resistance or the capacitance is changing, the unit will stay on until it stabilizes. That can be a very long time, and there's no easy way to turn it off once it's on. If you hold in the power button, it doesn't switch it off, it just restarts it. and does the component test again. Then you have to let it time out for it to shut off. So I'm pretty sure what I'm going to do is put a switch in line with the battery bank that I'm going to be using as the power, and I'll use that to switch it on and off after each test. I don't know if that will potentially do any damage to the unit, but it will certainly make it a lot quicker for testing things. All in all, from what I can see, it's a very nice little component tester, and I'm really looking forward to hacking it and playing with it. Unfortunately, my AliExpress orders are very late. None of the items I need to start playing around with this have come in yet. Hopefully once those items come in, I can do a video and show my results of playing around with this. If you enjoyed this episode, don't forget to give it a like and subscribe if you haven't already. If you didn't enjoy it or you hated it, then of course feel free to give it a dislike, and if you want, send me some feedback. If you'd like to share the video, feel free. Thank you for watching. I hope you have a wonderful day.